Okay, students. Now I told you inertial frame of reference is what? Non-accelerating. Non-inertial frame of reference is accelerating frame of reference. Now I'll give you a question. You analyze and tell me the answer. Okay. Okay, guys. Now listen, everybody. We have a lift, okay? Inside the lift, let us say we have one physics enthusiast. So he is taking his notebook and he is looking at the bulb which is hanging from the lift and he is writing Newton's laws of motion. He is writing Newton's laws for the bulb, like how we did for the horse and the cart. Like that, he is writing Newton's laws for the bulb. Okay. Now, one more physics enthusiast who is outside the lift, he is also seeing the bulb. No, so the lift is closed. How can you see it? No, have you seen in malls? Transparent. Okay, fine. So you have the bulb which is hanging, and this physics enthusiast who is standing in the ground, he is seeing the lift moving, right? Accelerating, coming down. He is also taking his notepad and pen and writing Newton's laws for that bulb. Now, can you tell me? I ask one question to you. What is the tension of the wire? Anyways, first of all, I want somebody to tell me what are the forces acting on that bulb. Let's say, let him be Mr. N and let him be Mr. E. Okay? Let's say, come on, tell me. Your good name? Jayant, tell me, Jayant. So, what are the forces acting on the bulb as observed by Mr. N? mg, very good. So, weight of the bulb is acting in which direction? Downwards. Is there any other force? Okay. Normal reaction will not act. See here. Give me. If I keep a book here, book is in touch, it is touching the table, correct? It is on the table, correct? What are the forces on this? Wait, don't jump. What are the forces on it? First, tell me. mg is acting downwards. If I simply keep the book here and leave my hand, what will happen? It will fall down. But I keep it here, it is not falling down. Why? Here, nothing is opposing it. Here, table is opposing it. With what? As a physics person, you must tell me. What force? We discussed this yesterday. It's very simple. What are the forces which are acting on this book to keep it as it is? One is mg, correct. Another one. Yes. Huh? Anybody? Somebody saying magnetic force, huh? Magnetic force, huh? Balanced force. That's correct. What is a balanced force? Come on, I'm getting answers here. What are the answers? What is the answer? Normal force, correct or not? Listen now. It is a contact force, students. Contact force. Listen, okay? Shh. Listen now. Listen carefully. So the book is on the table. There are two forces acting on it. One is in the downward direction. That you all know. mg. Wait. The table exerts equal and opposite force in the upward direction. That force is called what? Normal reaction force. Or simply you can say normal force or reaction force or normal reaction. Correct? Now, normal reaction will only happen. What is the necessary condition? The body must be on the surface, correct or not? Yeah. So tell me now, is the bulb on the surface? So normal reaction is so told, right? Tell me now. Mg is clear. Mg is acting downwards. Tension. Okay. Whenever there is a string, it is tension which is acting. Okay. Okay. Come on, ma. So now write the equation. How will you write the equation? Like what we did for the horse. Don't worry, I can. Don't worry about only vertical direction we are talking about. So no need IJ, nothing. Tell me. Why N? Where is N coming? What is N? Quick, ma, we don't have much. Come on. No sin theta. Where is theta? There. Sit down. Sit down. Where is theta here? Okay. Come on, anybody, tell me, ma. Quick. Yes. Get up. Evelyn. Quick. So on the bulb, what are the forces? Tell me. Mg and tension, that's all right. So the person who is standing in the lift, Mr. N, when he writes in his notebook, what will he write? Tension is in the vertically upward direction. Mg is in the vertically. According to him, the bulb is moving or at rest. At rest. So what will he write? It's a balanced force according to him. So what will he write? Net force is 0. Very good. Give a good round of applause, students. So according to Mr. N, who is there inside the lift, when he writes the equation, according to him, he is also inside the lift, right? The lift is moving. But according to him, is that bulb moving according to him? No, right? Relatively, it is at rest. For example, both of you are sitting in a bus which is moving. According to you, is he moving? No, right? He's at rest with you, correct or not? Similarly, Mr. N is standing inside the lift and the bulb is there. According to Mr. N, what is the bulb? Moving, not moving? Not moving. So according to him, the balanced force on the bulb, there is balanced force acting, which means net force is 0. So net force is 0 according to him. So what are all the forces acting, students? Mg and tension. So Mg, if I take it as positive, then tension will be what? Minus. Or I can take it as tension as positive, Mg is negative. Whatever be the case, I will write the equation as what? Either Mg minus T or T minus Mg. Do you understand, students? Mg is the force acting. And tension is the force acting along the wire in the upward direction. Is it clear to everybody? Why did I subtract them? Because they are in the opposite direction. So he will write Mg minus T equal to 0. So according to Mr. N, what will be tension? T is equal to? You take Mg to the other side. So what will be? T is equal to Mg. Suppose mass of the bulb is half kg, let's say. Or let's say mass is okay, ma? What is the mass of the bulb? 100 gram. What is acceleration due to gravity? Let's take it as 10 meter per second square. Now, Mr. N, what will he be reporting the tension as? Come on. 100 mg into, not mg, 100 gram into 10 meter per second square. 100 gram is how many kilogram? 1 by 10. So 1 by 10 into 10 is 1. So he will say tension on the wire is what? 1 Newton. Now let us say Mr. E, he is in the ground, he is writing the equation. Now what will be what will be the free body diagram for him for the same bulb, and what will be his value for tension? Let's say the acceleration is 5 meters per second square. Anybody can think of how do you write the equation? Tell me the answer, I'll give you a minute. According to him, what will be the answer for tension? Okay, let me tell you guys, okay? See here, I'm taking that bulb as a point object. Now, what are the forces acting on that bulb? Mg is acting downwards. What is acting upwards? Tension. But according to Mr. E, is this bulb moving or at rest? Moving. With what acceleration? 5 meters per second square. Correct? So how will he write it? Let me write it for you. Mg is acting in the downward direction. Tension is acting in the upward direction. But resultant of these two, which is greater, tension or Mg? Tension or Mg? Mg. Why? Because the body is coming down. Therefore, the resultant acceleration is in which direction? Resultant acceleration is in which direction? Correct? So how will be his equation? What is the net force equal to in this case? That case, net force was 0. Here, net force will be equal to? Louder? What is net force, ma? Newton's second law. M into A. Net force is equal to M into A. But what is net force? Two forces are there. What are they? Mg and tension. Mg is acting in which direction? T is acting in which is greater? Mg. So should I write as Mg minus T or T minus Mg? Mg minus T is equal to what? Ma. So bring T to the other side. Correct? Minus T is Ma minus Mg. T will be Mg minus Ma. So let's see. Net force is mass into acceleration. What is net force? Mg minus T. So T will be equal to what? Mg minus Ma. If I take M outside, it's G minus A. G is 10. A is 5. M is 100 gram. Yes. So when I calculate, what do I get tension as? 0.5 Newton. Right? So I give you the options now. The tension on the wire, first option is 1 Newton. Second option is 0.5 Newton. Third option, it may be 1 Newton or 0.5 Newton. It depends on where you are calculating from. Fourth option, none of the above. Or in other words, I'll ask the other question in a different way. The tension on the wire of the bulb, string of the bulb is as told by first option, Mr. N. Mr. N is correct. Mr. N is correct, E is wrong. Second option, Mr. E is correct, N is wrong. Third option, both of them may be right. It depends on where you calculate, accordingly, tension will change. Fourth option, none of these. It depends, is it? So if I stand in the lift and write the equation, the wire will know that I am standing here and it will give 1 Newton tension, correct? I am down on the floor and writing the tension, the wire will know that I am standing down now outside. So it will change the tension to 0.5 Newton. Is it correct? Do you understand what I am saying? When you say that the tension will depend on where I am standing, do you think then is it some AI, guys? It will adjust according to where I am standing. Does it impact in any way? It is independent, right? The wire produces a particular tension, correct or not? It is independent of whether I am there, whether somebody else is there down ground floor, correct or not? So what is right answer? Definitely anything else can be right, but C is definitely not the right answer, correct? Both cannot be correct, yes or no? Do you understand my point, guys? Will the tension change depending on, who is writing what? Correct. But that's not the option, no? They should tell me what. None of the above? Both, you mean both are wrong? Sorry? No, I am saying I didn't say both are correct. I didn't say both are correct. Okay, man, now listen everybody. Students, listen to this point. I'll tell you the answer. Anybody can tell me the answer? Who can say? N is wrong. Why? Okay, fine. Sierma, you got round of applause. Enough. Good. Mr. E is correct and N is wrong. Mr. E is correct and N is wrong. What is the mistake Mr. N is doing? Where is he standing inside? He is standing inside a non-inertial frame of reference and trying to apply Newton's law. Newton's laws cannot be applied to accelerating frame of reference. This lift, if it was not accelerating, if this lift was not, is it accelerating or not? If this lift was not accelerating, then Mr. N would have been correct, yes or no? But Mr. N is sitting inside a accelerating frame of reference and still writing what? Newton's laws. I told you in the beginning, Newton's laws cannot be applied to what? Non-inertial frames of reference or accelerating frame of reference. Your lift, which is accelerating with acceleration A, is dash reference. Non-inertial frame of reference or accelerating frame of reference. Newton's laws will fail if you try to apply them sitting inside a non-inertial frame of reference. So, Mr. N is wrong. You guys, number one. Point number two. Suppose I want to still be inside the accelerating frame of reference. Listen now, listen to this point very clearly. I want to be still sitting inside or standing inside non-inertial frame of reference, but still I want to use Newton's laws. Then I have to make a correction. What correction I have to make? I have to assume a pseudo force. Then my answer will be correct. Then I will be accounting for something. Is that clear? So I am sitting inside a non-inertial frame of reference, and if I write Newton's laws as usual, it will fail. Clear? Is the first point clear? Second point. If I am sitting inside a non-inertial frame of reference or accelerating frame of reference, and I still want to use Newton's law, I have to use one correction. That correction term is called pseudo force. I have to assume that a force is acting on the body. Okay. what force I should have assumed, and the force must be assumed to be in the direction opposite to the direction in which the frame is accelerating. I repeat once again. If I'm sitting inside this frame of reference, which is accelerating, I cannot apply Newton's laws. If I still want to apply Newton's laws, sitting inside accelerating frame of reference, then I have to assume a pseudo force to be acting on that object in a direction which is opposite to the direction in which my frame is accelerating. I will exactly follow that instruction, okay? Frame of reference is accelerating in which direction? Downward direction. Pseudo force must be taken in which direction? Upward direction. And that pseudo force should be equal to mass into that acceleration. Pseudo force must be equal to what? Mass into the acceleration of that frame. Okay. Now let us make that correction and again do it. Okay. So Mr. N attended this class today and he is going again and writing it now. Okay. What is he going to do now? Is it enough, guys? I need to assume what? Pseudo force. In which direction? Opposite direction. The lift is accelerating downwards, so I must assume a pseudo force to be acting in which direction? Opposite direction. This is the pseudo force. What value? What value? MA. Is it clear to you? Now let him try to write the equation. Is the what correction I have applied? Did you understand? I have drawn with the black ink. Okay. Now let's do it, guys. Now, according to Mr. N, what is this bulb? Is this bulb having any acceleration? According to the Mr. N, relatively, the bulb is at rest, which means it is acted upon by what forces? Balanced forces, which means the net downward force must be equal to what? Net upward force. What is the downward force? What is the upward force after the correction? MA. One more is there. What is it? Tension. So what is the total force? MA plus T. Now he will make the correction. Now what do you think his answer will be? Now Mr. N is also correct. Only after applying the correction. Is that clear, students? What answer is Mr. N getting now? 0.5 Newton. Why is he getting this answer now? Because he has added something else. What? Pseudo force. Why he has added pseudo force? Because he is sitting inside a accelerating frame of reference. He cannot apply Newton's laws as it is. So he must assume a pseudo force to be acting. In which direction? Opposite to the direction of the acceleration of the frame of reference. The moment you do that, it's over. Did you understand? Is the concept of pseudo force clear to you? Is the concept of inertial, non-inertial frame clear to you? Yes, that's it. Now we can go back to the slides. Yeah, take it down. Okay, students. Okay, students. Good. Now let's move on. Okay. Students, already I have explained to you. We will just go through it. So, what is called inertial frame of reference? Non-accelerating frame of reference in which Newton's laws of motion are applicable. These are called inertial frame of reference. Basic laws of physics are identical in all inertial frame of reference. Inertial frame of reference are also called what? Newtonian or even Galilean frames of reference. Non-inertial frames, very important. Frames of reference in which Newton's laws are not applicable are called non-inertial frame of reference. Such frames accelerate relative to inertial frames. Is that clear? They will have acceleration. Okay, for example, an accelerating car is an example for what? Non-inertial frame or accelerating frame of reference. Car going around a curve. Why? Even though the car going around a curve is not changing its speed, it is changing its direction. If it changes its direction, then velocity is changing, which means there is centripetal acceleration. Whenever there is acceleration, it is accelerating frame of reference. Merry-go-round, you know that. That's again a accelerated frame of reference. Artificial satellite. Again, anything which undergoes circular motion, right? It may not change its speed, but it has what? Centripetal acceleration, a force acting towards the center. Accelerating elevator, that's what we were talking about. All these are examples for non-inertial frames. What is the other name for non-inertial frames, students? Accelerating frame of reference. Inertial frame of reference, other name is what? Newtonian or Galilean, okay? Or non-accelerating frame of reference. Very good. Okay, ma, all rotating frames are non-inertial. Why? All rotating frames, there is a centripetal acceleration. They're rotating about something, isn't it? Earth. So then you can ask a question. Earth is rotating around the sun, isn't it? Did you ask that question? Good. Okay. So Earth is rotating around. So ideally, Newton's laws are not 100% applicable. We are all sitting on Earth and doing calculation in our physics class, correct or not? But where are we sitting, guys? On something which is accelerating. Then we should actually assume a pseudo force, correct or not? But for all our practical purposes, Earth can be considered, the acceleration that is produced by the Earth is very, very small. So you can neglect it. You can approximate it to a inertial frame of reference. That's why we are able to simply apply Newton's law and move on. Okay, however, in most applications, Earth can be approximated as an inertial frame because the acceleration is very small or negligible. Okay, come on now. I'll ask somebody. Yes. Can you answer this? Frame of reference in which Newton's laws are applicable. It's correct. Just see if anything else also might be answered. Yes. Non-accelerating frame of, that is another name for what? Therefore, the right answer is what? Both A and C. Good. which is an example for, yes, let me ask the question. Yes, I got the answer. Okay. Come on. Which is an example for non-inertial frame of reference, normal force, tension, artificial satellite, muscular force. Artificial satellite is correct. Because you know what is artificial satellite doing? Any body which is rotating is what reference? Accelerating frame of reference or non-inertial frame of reference, because it has centripetal acceleration. Good, very good. Okay, now pseudo force and its applications. We just saw one application. I just gave you that Mr. N and E example was what? An application. Okay, guys, observe that when we're traveling in a car and if the car hits the wall, then we will feel a push in the forward direction. How can we explain this phenomenon? Using Newton's laws of motion, we can't explain this phenomenon. Because according to Newton's law, only external force can change the motion of the body, correct or not? Yes or no? But here, something internal is happening, yes or no? He is pushed from the inside, correct or not? So this force cannot be attributed to any external force, right? So you'll be, because you are in an accelerating frame of reference. However, the push that we experience in the car is due to our own inertia, isn't it? Correct or not? But that should not change the motion of the body, correct or not? But it is changing, right? The guy is going through a rotational motion, correct? In order to apply Newton's laws to explain the situation, we need to introduce a term called external force in this equation. What is the external force called? Pseudo force. This added term, which does not have real origin, is called pseudo force. Now, did you understand it clearly with the example of the lift, which I told you? Yes, that's it. Okay, so what is pseudo force? Definition: force acting on an object relative to an observer in a non-inertial frame without any interaction with any other object of the universe is called pseudo force. Don't worry about it, just the definition. So you have to understand it is applied only whenever you are dealing with what frames of reference, students? Non-inertial frame of reference. Applications. So you can see that normally if this is a smooth surface, what will happen to this? What will happen now? It will slide down, correct? But if you give enough force horizontal direction, then you can make it not fall down. Possible. So that is because of pseudo force, which will be acting on the block. So now see, please observe carefully. If you do not understand, I will go to the board and explain it once more. So these are very, very important. So you have mg, which is acting vertically down. If this angle is theta, this angle will also be theta. Simple geometry. Whatever is touching the theta will be cos component. So mg cos theta, mg sin theta. So mg sin theta acts on the block, making it to slide down. Now, when you give an acceleration to this block, then this box which is on the block will not move. There is a possibility that it need not move. And that can be attributed to pseudo force, Ma. And Ma can be resolved into two components, Ma sin theta, because according to geometry, this will be theta. So this is Ma cos theta, this is Ma sin theta. This Ma I am resolving into Ma sin theta and Ma cos theta. Already there is Mg cos theta here. Here there is Mg sin theta. If Mg sin theta is equal to Ma cos theta, then the block will not move. If Mg sin theta is equal to Ma cos theta, the block will not move. If you equate them, M and M will cancel. A is equal to A cos theta is equal to G sin theta, or A is equal to G tan theta. Right? If you did not follow, I will explain once more. And the applied force. What is the applied force here? Capital M, which is the mass of this big block, wedge, and small m, which is the small block. So M plus M is the total mass into acceleration. And that acceleration, we just got it as G tan theta. So that will be the expression for the applied force. Okay, students, anybody wants me to explain this again in more detail? Okay. I just go to the board and we will explain this. Please observe carefully. I hope you are clear with the syllabus for your upcoming exam for physics. Complete first chapter, complete second chapter, complete third chapter, complete fourth chapter. All the, so your units and dimensions, then what? Motion in a straight line, motion in a plane, Newton's laws of motion, complete. Not up to any part or anything like that. Complete chapters. Students, now listen. What is the angle of inclination here? Theta. Now let me keep a block there. A block of mass m. The mass of the wedge is capital M. Now, can you tell me what are the forces acting on small m? Gravitational force will always be which direction? Vertically down. So gravitational force will be vertically down. Is there any force that is acting on the small m? Any other force? Normal reaction. Excellent. And how will the normal reaction be? Perpendicular to the surface of contact. So here the inclined plane is like this. So your normal reaction will be perpendicular to that. Okay. Well, come on, tell me now. So the normal reaction will be in which direction, students? Perpendicular. Very good. So far, okay. Now let's do a little bit of geometry, guys. What is this angle? Come on, tell me. 90. And what is this force? Force is mg. Now, can you tell me what is this angle? What is sum of all the angles in that triangle? In this triangle, what is sum of angles? 180 degrees. Out of that, it's a perpendicular 90 degrees, right? Right angles 90 degrees. And the other one is theta. So what will be the other one? Louder. 90 minus theta, right? So other angle will be 90 minus theta. Because 90 minus theta plus theta is 90, 90 plus 90 is 180. Understood? Now, I am resolving this mg into two components. One parallel to the plane, another is what? Perpendicular to the plane. Now, can you guys tell me what is this angle? And why? What is this angle? Theta. Because the other angle is what? 90 minus theta, right? We just found 90 minus theta. But total angle is how much? What is this angle, guys? 90 minus theta. What is this angle? 90. So what should be that angle? Theta. 90 minus theta plus theta gives you what? 90. So are you clear now? Did you understand why it is theta? Yes. Okay. Now, so the vertically down force is what? mg. So what is that component? The one which touches theta? Cos. So what is that? What is this component, students? mg cos theta. What is the component which is along this plane? mg sin theta. So, which is responsible for bringing the block down? mg sin theta. Very good. Now, If suppose the surface of the inclined plane was rough, then what will act? Friction will act in which direction? In the opposite direction to mg sin theta. Here we need not bother about it because we are considering what plane? Smooth plane. So friction is negligible, okay? Now let's talk about something else. So we are going to accelerate this frame, okay? I'm going to apply a force here. How much is the force? Mass into acceleration. Therefore, this frame is basically what? Accelerating in this direction. Are you clear with this? So the frame is accelerating in this direction, which means, can I write Newton's laws for that block? No, I'll fail writing that because I'm writing for a block which is in what system? Non-inertial or accelerating frame of reference. So I cannot write Newton's laws. So what I should do? Yes, I should assume a pseudo force. In which direction? The wedge is moving in which direction? Towards the right. So I must assume my pseudo force in the opposite direction, to the left. Very good. So what is that green line representing, guys? Pseudo force. What should be the magnitude of that? M into A. What is it? M into A. Now, once again, a little bit of geometry, guys. Now this MA, I'm going to resolve it into how many components, ma'am? I have indicated by yellow color. 2 components. One along the plane, another one is what? Perpendicular to the plane. Now again, little bit of geometry. Just tell me, guys, very simple geometry. If this is theta, what is this angle? 90 minus theta, because total is 90. If this is 90 minus theta, what is this? Theta, exactly. So this angle will be how much? How much will be that angle, children? Theta, right? Or even you can apply what? Corresponding angles. So here the angle is theta, then what will be here? Theta, right? 2 parallel lines cut by transversal. You have learned in your lower classes, right? See here, this is one parallel line. This is green line is another parallel line. This incline is a transversal. So what is this? If this angle is theta, what is this angle? Corresponding angles, correct? You can use multiple methods to get it. So are you clear with this? Now once you are done with this, then you can write the components. So MA can be written as what? 2 components. So along that direction, what is it? MA cos theta. Along the down direction? Yes. Yes, students. So your normal reaction, the net upward force. What is the net upward force? Perpendicular to the plane in this direction. Along the normal. What is the force? N. What is the force downwards? Mg cos theta plus Ma sin theta. So normal reaction will be equal to Mg sin theta plus Mg cos theta plus Ma sin theta. What about Mg sin theta on the, which is taking it down, will be equal to what? Ma cos theta. So when Ma cos theta is equal to Mg sin theta, the small block will not move. Is anybody supposed to join that session? Yourself? Anybody else? No, not choir group. Okay, that's fine. But otherwise, no. So I asked them to take the permission from their father because this class is quite important. I think he has declined. Okay, now, So do you understand so far? How many of you understood so far? It's clear. They're not clear. Okay, now. Okay, now really nice. So MA cos theta, when it is equal to what? Mg sin theta, the small block will move or will not move? Will not move. That's the condition we are talking about. Although the surface is smooth, it can't move because you are applying a force. Correct? So MA cos theta will be equal to Mg sin theta is the condition for the block not to move. So what cancels, students? M gets cancelled. So what is A equal to? Yeah, sin theta by cos theta is tan theta. So are you clear with this now, students? So did you understand till here? A is equal to G tan theta. Okay. Now what is applied force going to be? Okay. No. So what is applied force is equal to what is this total mass? M. What is the small mass? Small m. So what is the total mass of the system? M plus m. The entire mass is accelerating with what acceleration? A. So what is, according to Newton's law, what is F equal to? Ma. So it is m plus m into A. And what is A? That's it. So did you understand it now? Clear? So we have a few more applications of pseudo force which will be helpful for you. With that, we will stop today's session. Okay, we need not do the derivation, but just you can understand. So let's say when a car is moving forward, if you hang a pendulum, what do you think the pendulum will do? It will move on the other side, yes or no? That's because of the pseudo force, okay? So now, so Ma is the pseudo force, Mg is what? The gravitational force. What is here? Tension. Right? Let's say the tension makes an angle theta with a vertical. Then tension can be resolved into how many components? Two components. T cos theta will be in which direction? Vertical direction. T sin theta will be in the horizontal direction. T sin theta will balance what? Ma. T cos theta will be balanced by Mg. You can see that. Okay, right now, okay, so much analysis also not required. We just, the car is moving with uniform velocity. What will happen? The position of the bob will not change. Suppose the car is moving in this direction, then the pendulum will shift in the other direction because pseudo force is in the other direction. So if car moves with an acceleration or retardation, the bob moves in the opposite direction to that of acceleration. That is very clear to you. The car is moving this way, bob is moving to the left. If the car is moving to the left, bob will move to the right. Force acting on the bob are Mg. Yeah, this is what I was talking about. You can see here, tension is acting here, Ma is acting here, Mg is acting here. And what is this angle? Theta. If this angle is theta, what is this angle? Theta, right? Because alternate angles. So this is theta. So what will happen? T cos theta, T sin theta. T sin theta is balancing Ma. T sin theta is balancing Ma. T cos theta is balancing mg. If you divide the two equations, m and m will cancel, you'll get a by g. T and t will cancel, sin theta by cos theta is tan theta. Once again, you are getting a is equal to g tan theta. Same as what we got previously. Here it's much more simpler, right? Because you're not dealing with an inclined plane. Okay, students. I think it's already time, so we will conclude here and then we'll move on, right? So we'll be discussing few more examples in pseudo force and then we'll move on to very important topic, friction. Just before friction, we can complete law of conservation of linear momentum. Very important question for your coming quarterly examination. Come prepared, okay? So I have the names of students who did not answer, boys. Okay, can I expect you to answer tomorrow? Yes, no, will you come prepared? Sure? Okay, guys, all the best. Girls also. Okay, first, whatever, I'll choose a session where I'll reserve only for questions. Okay, all the best, students. Thank you.